Chapter 1, Section 7, Physics Talk, Circular Motion, Centripetal Force. In the Investigate, you observed a toy car moving in a circle. The car required the force of the string to keep it moving in a circle. When you let go of the string, the car traveled in a straight line. There was no longer a force on the car to keep it moving in a circle. This motion can be explained using Newton's laws, which you will study in more detail in other chapters. Newton's first law of motion states that an object in motion will stay in motion at a constant speed and travel in a straight line unless a force acts on it. When you let go of the string, the car traveled in a straight line, since no force was acting on it. Anytime you observe something moving along a curved path, you should recognize that there has to be a force acting on the object. The force of the string keeps the toy car moving in a circle. This force of the string is always toward the center of the circle. In a similar way, the force of friction between the block and the turntable kept the block moving in a circle. This force of friction is always toward the center of the circle. When an automobile makes a turn, it is traveling along part of a circle. There is a force of friction between the tires and the road that keeps the automobile moving in the circle. Eliminate this friction, which is what happens on an icy road, and the automobile will move in a straight line and will not be able to turn regardless of what you do with the steering wheel. This force of friction is toward the center of the circular curve. The force that keeps an object moving in a circular path is called centripetal force. The centripetal force can be the tension in the string, the friction between the block of wood and the surface of the turntable, or the friction between an automobile and the road. For Earth moving in a circle around the sun, the centripetal force is gravity. For a baseball bat moving in a circle during a swing, the centripetal force is the force of the muscles in the batter's arms. As the toy car moves in a circle, its speed remains the same. It does not appear to go faster or slower. Its velocity does change because the direction is changing. The car is changing its direction. For a moment, it is moving east, then it is moving south, then it is moving west, then north, then east again as it starts its next revolution. Changes in velocity with respect to time are called accelerations. In the previous sections, you associated accelerations with changes in speed as a vehicle sped up or slowed down. A vehicle that is changing directions is also accelerating. The acceleration associated with an automobile changing directions is referred to as centripetal acceleration. Centripetal acceleration. Acceleration is the change in velocity with respect to time. Velocity can change when an object speeds up, slows down, or changes direction.